Now the third transformation that we will study is transformation of the general equation ax plus by plus c equals to 0 into normal form. And what was your normal form? X cos alpha plus y sin alpha equals to p. Now, there are two things that we should take care of once we want to convert our general equation into normal form. First thing, in normal form we had discussed that coefficient of x and coefficient of y, square of coefficient of x plus square of coefficient of y should always be 1. And second thing, the right hand side has to be positive. Why? Because the right hand side is telling you the distance of the line from the perpendicular distance of the line from the origin, and distance is always positive. Therefore p has to be positive, and p is on the right hand side. Therefore right hand side of your equation should be positive, and the coefficient of x square, sum of square of coefficient of x and y should always be 1 if you want to convert your equation into normal form. So what we say is, now if this is your general form of your line and the normal form is x cos alpha plus y sin alpha minus p equals 0, bring all the terms to the one side. Now these two equations are same because we want to convert this into normal form. If we compare, since these two equations are equal, they are coincident lines. Therefore, what condition should they follow? A1 upon A2 should be equal to B1 upon B2 should be equal to C1 upon C2, because both lines are same. We just have to convert one form into the other. Therefore, A upon cos alpha is same as B upon sin alpha is equal to C upon minus P. Therefore, what we can say, what is cos alpha? If we equate this to this, what is cos alpha? Cos alpha is minus A into P upon C. Similarly, what is sin alpha? If we equate this to this, sin alpha would be minus B into P upon C. Now, what is the relationship between cos alpha and sin alpha? Sin square alpha plus cos square alpha should be 1. Now, put these values. Therefore, B square P square upon C square plus A square P square upon C square is 1. Now, we can take P square upon C square out. We have A square plus B square equals to 1. Therefore, what is P? P is what? C square upon A square plus B square under root and plus minus. So this comes out plus minus under root A square plus B square. Therefore, since P is always positive, since it represents the length, since P is always positive, therefore we take P equals to C upon under root A square plus B square. Now, what is, therefore if we put the value of P in the equation, what do we get? We get in this equation. So what is cos alpha? Cos alpha is minus A upon C. What is P? C upon under root A square plus B square. Similarly, what is sin alpha? Minus B upon C. P was C upon under root A square plus B square. So C and C goes away. So cos alpha is what? Minus A upon under root A square plus B square. And what is sin alpha? Minus B upon under root A square plus B square. Therefore, so your equation takes the form. What does your equation take the form? X cos alpha, therefore minus AX upon A square plus B square plus B sin alpha, that is minus BY upon under root A square plus B square is equal to P. And what was P? Minus, we had written minus P. So minus C upon A square plus B square equals to 0. Now, what we can do is now minus AX upon under root A square plus B square plus BY upon under root A square plus, or rather minus A square plus B square. We'll take this to the right hand side. Therefore, it becomes C upon under root A square plus B square. So what we have done is, this is your normal form. What we have done is, we started out with ax plus by plus c equals to 0. Keep the constant part positive. What we are doing is keep the constant part positive. If it is on the right hand side and positive, keep it on that side. Otherwise, keep it positive. Therefore, c is positive. We'll take both these terms to the right hand side. Minus ax minus by. And what we will do, we'll divide by the coefficients of sum of squares of coefficient of x and y and take its under root. That is a square plus b square, a square plus b square and a square plus b square. Once we do this, we get our normal form. Why? Because right hand side is positive. And what is the coefficient of x? Coefficient of x is minus a upon under root a square plus b square. What is coefficient of y? Minus b upon under root a square plus b square. Their sum of squares should be 1. Let's see what their sum of squares is. A square upon a square plus b square. And what is this? B square upon a square plus b square. LCM is a square plus b square, and in the numerator we get a square plus b square, and this cancels out and gives you 1. Therefore, both the conditions have now been met and we have successfully converted our general form into normal form. So now we'll take an example of this to understand the concept. Let's say we have 3x minus 4y plus 5 equals to 0. This is your general form. We want to convert this into normal form. Look at the constant. If it is positive, keep it there and then. If it is negative, take it on the other side. Now since constant is positive, we'll keep it on this side only and take both the terms to the other side. We have 4y minus 3x. This is step 1. We have made the constant part positive. Now what we'll do, we'll see the coefficients of x and y and square and add them. What do we get? We get 5. We divide by 5 throughout. What do we get? 4 by 5 by minus 3x by 5 equals to 1. This is your normal form. Right hand side is positive. And what is 4 by 5 square? 16 by 25. What is 3 by 5 square? Minus 3 by 5 square. This is 9 by 25. If you add them, 16 plus 9 upon 25 gives you 1. Therefore, what is cos alpha? Cos alpha is x cos alpha. Therefore, minus 3 by 5. And what is sin alpha? 4 by 5. Now, where does alpha lie now? We can also find out where does alpha lie. Cos alpha is negative, and sin alpha is positive. So therefore, it lies in, alpha lies in which quadrant? Cos alpha is negative, sin alpha is positive. Alpha lies in second quadrant. Therefore, the perpendicular from the origin to our line is making an angle which is lying in the second quadrant. Let's say this is our line. This is the perpendicular from the origin. This is 90. This angle is what? Alpha. Alpha is lying in which quadrant? Second quadrant. Therefore, you can also find out the approximate image of your line. This is how you can find out where alpha is lying and where your line is lying, by noting the sign of sin alpha and cos alpha. By noting the sign of sin alpha and cos alpha, you can find out in which quadrant alpha is lying. Alpha tells you the slope or the inclination of your perpendicular, and on the basis of that, you can find out the nature of your line or the shape of your line. Let's take another example on it. Let's say we have 5x plus 12y plus 3, or rather minus 3 minus 13 equals to 0. So in this case, this constant part is negative. What we'll do, we'll take it to the right side. 5x plus 12y is equal to 13. Step 2, what are the coefficient of x and y? 5 and 12. Square them and add them and take their under root. This is 144 plus 25, 169, which is 13. Divide the whole equation by 13. 5 by 13x plus 12y by 13 equals to 1. Now, this is your normal form. This is your normal form, because the right hand side has become positive and the coefficient of x and y, their square sum is 1. Now, what is cos alpha? Cos alpha is 5 by 13. What is sin alpha? Sin alpha is 12 by 13, because we have converted this into normal form. We can compare P and sin alpha and cos alpha. Now cos alpha is also positive and sin alpha is also positive. Therefore, the alpha, the inclination of the perpendicular from origin to our line, is lying in which quadrant? In the first quadrant. Therefore, your line will be like this, because alpha is lying in first quadrant. This is P. Therefore, your line will be passing through the first quadrant. This is how we can find the not only the normal form, but we can also predict the shape of our line.